Good morning and or afternoon, everyone. My name is Muhammad Imran bin Anwar, and today I will be presenting my project titled Iris Recognition using Convolutional Neural Networks for Biometric Security Application. Okay, this project explore how deep learning, especially CNNs, can enhance the reliability and accuracy of iris-based biometric systems. So, for the next slide is a problem statement. Let's begin by addressing the core problem. Traditional security methods like password, pins, or even access card are vulnerable. They can be hacked, stolen, or easily duplicated, while iris recognition offer a more secure alternative. It's not perfect, but the main challenge include variation in lighting, partial occlusions, and noisy image data, all of which can reduce recognition accuracy. Okay, and then this project can tackle these issues by leveraging CNN, which are excellent at pattern recognition in image. So for the next slide, we go to the objective, which is the main objective of this project were twofold. First is to improve both prediction speed, clarification, accuracy by applying appropriate preprocessing and optimizing the CNN model. Second, to build a CNN that reliability classify every image into discrete identities, making it a viable tool for biometric security. Okay, so we go to the next slide, which is database descriptions. The database use of the iris eye dataset, which is from Kaggle. It's consists of roughly 1,000 images categorized into 30 folders representing a different individual. Okay, the data was used, about 80% of data was used for training and 30% for validation. The image may vary in lighting condition and iris sizes, adding some natural complexity to the classification of tasks, where the labels were automatically assigned by only folder names. Okay, now let's look to the next slide, which is code explanations. The data was prepared and the model was built, which is first image processing. All image were sized to 128 times 128 pixel, which is pixel value were normalized between 0 and 1. Augmentation techniques like rotation, zoom, and brightness adjustment were applied to increase variability and robustness. Second, CNN model architecture, which is the model start with two blocks of conv2D, ReLU, and max pooling layer to extract features. After flattering a dense layer with 128 units and dropout of 0.5 is used to prevent overfitting. Finally, a softmax output layer perform the classification begins. And then we go to the training setup, which is the model was trained for 25 epochs, and it used ADAPT Optimizer and categorical cross-entropy as the loss functions. Okay, for the next slide is evaluation, which is after training the model, performance was evaluated using accuracy and loss graph, which show consistent improvement over epochs. A conversion metric to assess how well the model distinguish between the 30 classes. This tool helped verify the CNN was learning meaningful patterns in the iris image. Okay, as for the discussion, highlight the model's strength and limitation, which is the strength of the project is the model successfully learned to classify different iris pattern, and there was a steady improvement of training accuracy and decrease in loss, indicating effective learning, which is the project basically is great and berjaya, but the limitation is where the model perform well on training and validation set, its generalization ability is still limited, and this reveal the importance of having diverse and high quality data set when developing biometric systems. Okay, as for the conclusions, the project successfully demonstrated the potential of using CNNS for iris recognition. I built and test a deep learning model using Python and TensorFlow, which is showing promising results. However, to further improve real-world performance, we must focus on expanding the dataset and addressing generalization issues. And that's all from me. Thank you.